Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 7 for the April Daily LeetCode Challenge, and we again have a very good question. It's a medium level question, and if you see the acceptance rate, you will be bit, shocked. It is around 47% because believe me, it's actually something that you will not be able to get the answer because it's only for the premium users. Other than that, this question, if you see, they have not given much hints here, but it's very simple to understand. They don't need to give you much examples. It's because very simple to understand, but still it is very difficult to code because the way it is given. First of all, let me show the constraints. Though constraints are smaller, but again, you cannot go for exponential solution. Let me be very frank here. See, I think a few days back we tried a similar question regarding sets, and we went for the exponential approach. The idea is very clear. You cannot go for exponential approach in this case because the length here, okay, it is around 200. So if you go for exponential, it will be 2 raised to power 200. That many types of iterations are going to happen. Obviously, that is a very huge number, and it's not at all feasible. Okay, so we cannot go for exponential one, and we'll have to try something in between, like less than that. Okay, as simple as that. So let us see how to do this question. The question is basically about, you are given a nums array. In this case, all the numbers are going to be positive from 1 till 100. Okay, what you have to do is basically you have to return true if you can partition the array into two subsets such that the sum of the elements in both subsets is equal or false otherwise. Okay, so idea here is, see, for example, in this case, example number one, if you see this, the total in this case basically is, if you see, around 22. Okay, it is around 22. The total is 22. So what is half of 22? It is around 11. So if we are able to form a subset, okay, with the sum is 11, then we can return true. Okay, so that is what is the idea. If you can partition the array into two subsets such that the sum of all the elements in both subsets are equal. See, indirectly they are trying to tell you that each subset basically should have half the sum of the total subset. Okay, half the sum of the whole subset. Okay, so if you see here, in this case we are keeping 11 in one set and we are keeping 155 in the other set. Okay, so idea here is every element should be part of one set. Okay, as simple as that. There should be only two sets. All the elements will have to, you will have to choose whether each one of them will belong to the set number one or set number two. There are only going to be two sets, and the sum of the final, both the sets ultimately should be same. Okay, that is the sum of, that is, yeah, the sum of the elements of both the sets should be equal to half of this, the sum of the whole set. Okay, as simple as that. In this case is 22. 22 divided by half is 11. So if you see, the sum of this is 11, the sum of this is 11. Okay, that is what you have to do. Same as for example number two. You can go through it, but see, again, one very important aspect here is, since we are talking about this thing, okay, each side, the sum of the elements in both sides should be equal. Now see this case, if the total sum itself is odd number, so obviously odd number cannot be divided by 2. Okay, so we cannot divide it by, the idea here is we cannot achieve the same sum, if the total sum itself is half. Okay, I mean odd. So in that case we have exception. Okay, so see this case what we can do. So the first condition is you have to take the sum. Okay, and if the sum cannot be divided by 2, that is, if the sum is odd, we have to return false straightforward. Okay, we don't do any calculations, we don't do anything else, we simply return false. Then we calculate the target. The target is basically going to be the sum divided by 2. Okay, whenever I see 2 divided by simple, that basically means the integer division. Okay, the answer of this is going to be integer. Okay, as simple as that. Since we already know that it's a perfect division, that's why we are doing integer division here. Okay, next, since this question has been marked with a DP approach, if you see, this question has been marked with a DP approach, so that's why I got this idea of using DP, and I have tried it. Okay, so what I've done is, see, this is going to a slightly trivial problem. You may not have seen this kind of questions previously. See, there is a whole range of these questions. Okay, so what I will say is, see, LeetCode has not done a good work because they are directly giving this question. They should have given similar problems first, and then they should have come to this. That's what I felt is the right way. But again, they have not given that. Okay, so see here what we are doing. We are basically creating a DP array where it's obviously a Boolean array. It has only true or false values. Okay, the length of this is going to be up to target. Okay, that is, it has target plus one element. That idea here is 0 till target. Okay, all the elements in between them are there in this DP array. Okay, from 0 till target. So in total there are target plus one elements. Okay, so what is target? Target is basically the half, actually, the you can say the half of the total sum. Okay, target is basically half of the total sum, right? This particular number is going to play a very important role in the whole problem, as well as in the time and space complexity. So please pay attention to this. So basically we are creating a array, a DP array, whose length is going to be target plus 1. Okay, now see, what is this basically going to signify? The idea here is, see, DP of I is basically going to signify if we can have a subset, okay, whose sum is going to be I. Okay, so we have to try true or false here. Okay, if it is true, that means we can have a subset whose sum is going to be I, and if it is false, that means we cannot have a subset whose sum is going to be I. Okay, since a subset of sum 0 is always possible. Okay, because it could be empty set, right? So, so a set whose sum is 0 is always possible, so this will be the true, this will be always true. Okay, So I will again repeat, dp of I is basically if we can have a subset whose sum is going to be, whose sum of the elements is going to be I. Okay, simple as that. So if dp of I is equal to true, that means we can have a subset of some I. Okay, as simple as that. Now what I'm doing is, see, this is going to be a very trivial case. Please pay a lot of attention here. We are creating a for loop where we are going through each of the nums. Okay, we are creating a for loop where we are going through each of the nums. Now this is a very important part. This aspect, I think, it's something that you will not get in the first go. You'll have to keenly understand what is happening, because this is where the whole trick is coming. Now try to understand this fact. If, see, what I'm doing is, I'm starting from j, starting from target, and it is going till I. Okay, it is going till I. Okay, it is starting from target and it is going till I. So j will go from target till I. Okay, let me basically write it here. The j number, okay, is basically going from target till I. Okay, as simple as that. Yep, in a reverse direction, obviously, it's being decremented every time. Okay, in every iteration. So what I'm doing is, see very cleanly, I'm just trying to see if dp of j can be achieved or not. Okay, dp of j, if it can be achieved or not. So when dp of j can be achieved, it's very simple. dp of j can be achieved when we have a, say, dp of j minus 1, j minus I is 2. Okay, see, the idea here is, if dp of j minus I is 2, what I will do is, in dp of j, that is in j, basically I will add I. Okay, in j I will add I and get target. Okay, as simple as that, right? This is going to be the basic idea. Yeah, that's what, see, idea here is, see, we are talking about j. Okay, so I am trying to see how I can achieve the number j. Okay, how I can achieve a set whose sum is going to be j. When is that possible? That is possible if I have a set whose sum is j minus I. In that I will add I and I will get j. Okay, that is the basic idea. If a set is possible whose sum is j minus I, in that I will add the element I, and then I will get a set whose sum is j. Okay, as simple as that. So dp of j is possible if we have dp of j minus I is 2. Okay, so that's what we are doing. If it is already 2, then well and good. If it is not already 2, then we are just trying to see if dp of j minus I is 2 or not. If that is the case, then we can say, like, yeah, this is also possible. Okay, that is what we are doing. Now you will ask me why we are going in a reverse direction, like why we are going in a, I mean, from target till I. Okay, in a reverse way. The idea here is, we don't want the overlaps to happen. That is, see, each element obviously should be used only once, right? So I cannot say, like, see, you can add 0 from this 0 is that you add 1, you are getting 1. Okay, now again you are adding 1 to 1, you are getting 2. So those things are not possible, right? One can emit only once. So that is why, to ensure that we are doing in a reverse direction, basically. Okay, so once dp of j is calculated, it will not be used in the same iteration again. Please take my words. This is something I'm saying from my experience. Once dp of j is calculated, it will no more be used in the same iteration again. Okay, that is the basic idea why we are doing in a reverse direction, basically. Okay, we don't want it to be. Had we done in the other way, that is, if we made the j start from I till target, what would have happened is, once you calculate dp of j, it would have been reused in the same iteration. Okay, which is not correct, because you cannot add like the same number two times, right? You cannot do that. So that is why we are doing it in a reverse. So the way it works is very simple. We have the numbers I, right? We have this number I. Now we are just trying to see, like, where and all, we already have a set. We are just trying to add the I and see which all elements we can further get. Okay, that's what we are trying to do. So wherever this particular number is 2, we are just trying to see if there we can add I and get a new, set, new particular dp of j or not. Okay, as simple as that. And finally, this is done. What we are going to return is, we are just going to return dp of target. It is false by default, right? It is false by default. And in this, in this whole process, in these two iterations, if it became true, then we are going to return that as true. Okay, so let me quickly run this and show it to you. As you can see, this is clearing all the test cases, basically, right? I've also added some print statements initially, just for you to understand. Like, this is the one. If you want, you can, again, uncomment it and see how the output is coming. But yeah, the idea is very simple, guys. It's not a rocket science after all. See, what we're doing is very simple. The only thing is, to get this kind of idea, you will definitely need some practice. You will definitely need some examples. That's what I will say. This is definitely not rocket science. This definitely problem doesn't resolve 47.8. But the only thing is, that should have been some hints. Okay, they did not give that. So that is why, I guess, the acceptance rate is so less. And even at the end of the day, okay, I'm making this video almost at the end of the day, still the acceptance rate is so less. Okay, that is something really shocking to me. So friends, yeah, this is the solution. So this is the only part which I will say is going to be complex for you to understand if you have not done a similar problem before. Okay, so my request will be, take a pen and paper and draw and see everything what is happening. I will again repeat. Remember, usually we form the dp array of length n. This is not length n. This is for length of target plus 1. Okay, so this is the only thing where you will be, you will not be able to imagine why this is happening, why this works. So please take a pen and paper, draw and see how it works. Then you will get to know why it works. Okay, obviously this is not in a very, I will say, optimal way of of doing it. But again, this is better than the exponential solution that is in the brute force way. Okay, the exponential solution will be the brute force approach. Definitely, it is better than that. Okay, the exponential one will go to around 2 power. See, in the worst case, will go to 2 raised to the power 200. Okay, that is very huge number, right? Now, if we talk about space and time complexity of this solution, see, we are only going to create an array, right? So in terms of space complexity, we are going to O of S. What is S, by the way? S is going to be the target. Okay, what is target? Target is going to be the total sum of the elements divided by 2. Okay, total sum of the elements, that is total sum of elements present in nums divided by 2, right? That is S. Now if you talk about the time complexity, it's very clear here. So we are using two for loops. So first for loop is O of N, second for loop is O of S. Okay, so for each iteration of O of N, we are having O of S. Okay, so it is going to O of N into S. Okay, because for each iteration of this, we are going to have this loop running. Okay, this will run for around S times. So for each iteration of this, we have a loop which is running for S times. So in total, it's going to O of N into S. Okay, so yeah, that was all for this particular video. And yeah, I agree, this is not something which is common to you, which is see, the idea is you will not get this kind of idea if you have not seen a similar problem before. That's why I will say, like, LeetCode should have given a similar problem before, which is slightly on the easier side, which has some good hints. Then they should have come with this problem, but again, they did not do that. And more, but the reason why this example is so small is that, if you see at 47, is because they have not given the editorial. Okay, so many people are not able to carry this idea. Okay, and obviously, since the constraints are not very lenient, okay, you will not be able to get this, in a brute force way. Okay, as simple as that. Had this been an easy problem, had the length been around 12 or 11 or 10, 9, 8, then obviously using brute force also you can get, using simple exponential algorithms also you can get. Okay, so yeah, that was all for this particular video, and let me know your thoughts in the comment section about this question, what you felt when you tried this, and how you were able to overcome your fear and solve this question. Okay, what to learn from the solution, or what you think can be done in this question. So yeah, that was all for this particular video. If you like my content, please subscribe to the channel. This really gives a lot of motivation to continue further. And this I have completed on 167 days, including today, and there are many more days to come. So if you like my content, please subscribe. This really gives us a lot of motivation to continue further. See you tomorrow. Thanks a lot.